Okay, we've got two counters and two clear counters, so let's test. So here we are, and if I approach the container counter and I press the interact button, and nope, nothing happened. We cannot interact with it at all. Even the selection visual, even that one is broken. So as I approach, nope, the visual is not showing up. Now the reason for this is actually pretty obvious. If we go over here on the player script, down here when we're handling our interactions, so let's go into the handle interactions function. Over here we are doing a raycast and we are trying to get component of type clear counter. So basically we're not doing anything if that object has a container counter instead of a clear counter. So again, we have a similar issue to the one that we had in the object parent logic. Basically we have two types, a clear counter and a container counter, and we want the player to be able to interact with both of them. So as a solution for this exact same problem, we could also implement an interface just like we did. That would work, that would enable the player to interact with multiple counters. But in this case, since the counters are all very similar, very related objects, they're all going to be kitchen counters as opposed to object parents where the player and the counter are completely different. In this case, since they are all very similar, a better approach is actually to use inheritance. Now here I should point out that inheritance is one of those things that is simultaneously very powerful but also very dangerous. Usually beginners get really excited when they first hear about inheritance, but after gaining some experience they start to see the massive downsides. One funny joke about it is, let's say you want to write some code that all it needs is a banana class, but because of messy inheritance you end up with a monkey and the entire jungle behind it. Basically the banana extends a monkey, which extends a tree, which extends a jungle, and so on. So you just want a small thing, but because of a complex inheritance you end up picking up a huge object. So all of that to say, inheritance is something you must use very, very carefully. It's a powerful tool, definitely, but you need to make sure to absolutely use it in the right approach for the problem you're trying to solve. Now in this case, like I said, since all of the counters are going to be very closely related, in this case it does make sense. And of course in the future, if that does change, we can always refactor. If you're a beginner, definitely go ahead and research a bit more on C# inheritance, the pros and cons. I don't have any dedicated video on that topic myself, but if you search, I'm sure you'll find tons of content. Again, it's a very powerful but also very dangerous tool, so definitely use it wisely. Over here, let's make sure we're wise, so let's use it. First thing we need to do is define the base counter class, so let's create a new C# script. Let's call it the base counter. So over here on the script, let's get rid of the functions. We don't want any default functions. And let's also make sure that we do extend mono behavior. We do want that. We still want to use this as a component. So let's leave the script just like this. Let's save it. Then let's go over here into the clear counter script. And on this one, instead of extending mono behavior, let's extend the base counter. Okay, that's it. That's the only change. And now let's go into the container counter. And over here, same thing. Let's extend the base counter instead of mono behavior. So now both these counters extend the exact same base counter script. So now if we go into the player script, so here we are on the player script, and on the handle interactions function, over here instead of trying to get a component of type clear counter, let's try to get the component of type base counter. So let's also rename this, so Ctrl RR to rename this to base counter. And of course we need to rename all these references that expect a clear counter instead of a base counter. So over here for the selected counter, let's modify the type to base counter. Then also up here, when we've got the event args, let's modify the type, okay? So over here we have the interactor. Let's leave this for a bit. Let's go down and let's fix this issue. So let's go down into that function to set the selected counter. Instead of this type, let's receive a base counter. Okay, so all of these errors have been solved. There's only one left, and it's this one, the interact. We see this error because obviously the base class does not have any kind of interact method. So let's add that. Now for adding methods to a base class, it's actually very simple. It's really just like any other method. So first the accessor. For the interact, we want the player to be able to access it, so let's make it public. And also since we're talking about inheritance, I should probably mention the other accessor. Now you already know about public and you also already know about private, but there's another one you might not know, which is called protected. Basically, this one means that whatever function we define with this accessor, it is going to be accessible to this class and any class that extends it. So for example, if we had a function that was protected, the clear counter could call this function because it does extend this base class. However, the player would not be able to call this because it is protected. Now in our case, for the interact action, we do want the player to call it, so let's make it public just like we had previously. Then another keyword. For every function that we want the child classes to be able to implement in their own way, we can define it as virtual. And finally, the function signature as normal. So for the interact, we made a return void, call it interact, and we received a player argument. Okay, so that's it. That's our basic signature. For the implementation, let's leave it empty over here on the base counter. So by default, it's not going to do anything. In the game design that we're building, we're never actually going to end up with anything like this. So if we want, for safety, we can just add a debug.log error to say just base counter.interact, because this should never be triggered. Also, I should point out, for a more advanced method, instead of making it virtual, you could make it abstract. And basically what that does is that forces all of the classes to implement their own implementation. So you would make this abstract and just put it just like this, as if this were an interface. But in doing so, you would also need to define the base counter as abstract and so on. So basically this is a more advanced method, so don't worry about it for now. Let's keep it a bit more simple. So let's make it just virtual void interact. Okay, great. So we have this, let's save this. And now if we go on the clear counter, over here on the interact, notice how we have a green squiggle line. Basically, this is a warning. It's telling us that we are hiding the base function. Now, in reality, we don't want to hide it. Instead, we want to override it. So before the void, before the return type, we just add the keyword override. And yep, this will now override the base function. So when the player interacts with an object of type base counter, and that object is actually a clear counter, when the player calls the interact function, instead of running this code, it's actually going to run this code. Now let's do the same thing on the container counter. So over here, let's also add the keyword override to override the base function. Okay, great. So we have no errors here. And on the player, we also don't have any more errors since that one does now implement the interact function. So with this, let's test and everything should still be working. So over here, let's approach the interact counter and let's interact with it. And yep, it does work. It spawned some cheese. And down here, yep, it spawned a tomato. And then if we go onto the empty counter and interact, and yep, it still works. Okay, so here we added the ability to interact with two different counter types. All right, great. Now note how the selected logic isn't really working well. You can see the container counters, they are both selected, even though the player is not looking at them. And actually, if I approach it, then it actually becomes deselected. Basically, the reason for that is because the selected script, that one is still referencing the clear counter instead of the base counter. So right now, it's only being selected when the selected counter is null. So that is why as I approach, it actually hides itself. So let's fix this. Let's go inside the container counter prefab, and inside we've got the selected. And yep, over there we have a reference to that. So let's open up this script. And over here, all we need to do is just modify this type. So let's make it of type base counter. And let's rename this to base counter. Okay, that's the only change we need. And by the way, since we're here, let's also fix the other issue. The issue we had where we need to support more than one visual game object. So instead of having a field of type just game object, let's receive a game object array. So let's modify this to game object array. And then down here on the show hide is actually very simple. So let's just do a for each game object for the visual game object. In the visual game object array, we go inside, set it to true, and on this one we set it to false. Okay, that's it, super simple. Now let's just update the prefabs. So first over here on the container counter, let's drag the container counter reference as the base counter. Okay, great. And for the visuals, let's just drag all of them. So let's drag the counter solid, drag it on top, then the counter hole, drag it on top, then the signal door, drag it, and the black, drag it. And also, by the way, over here on this counter, this one actually has an object sprite. This is the actual sprite in there, but for the selected, we really don't want that. So if I enable this game object, here we've got the object sprite. Let's actually delete this. We don't need the actual icon sprite to be highlighted, so let's leave it just like this. So we only have these 4 objects, and all 4 of them are on the list. Okay, that's great. So all the references in here, they're all working perfectly. So let's go back outside, let's save the prefab, let's go inside the empty clear counter. And on this one, same thing, on the selected, let's drag the insider reference. And for the base counter, let's also drag that reference. Okay, so let's go outside, save it, and let's test. And now let's see if the selected works. So as I approach this one, yep, it works, and on this one, yep, it works, and down here, yep, it works. All right, awesome. So we can interact and we can highlight our selection. Okay, everything is working great. So now that all of the code is working, we can inspect the code to see if we can refactor anything. We can see, for example, if there's any kind of common logic that all of the counters share that we should probably write in the base counter. And you can see right away that both the clear counter and the container counter, both of them implement the kitchen object parent interface. That behavior is something that all of the counters will share. So instead of defining it on each counter itself, let's actually do it on the base class instead. So let's get rid of the interface implementation here, and also on the container counter, let's get rid of that. Instead on the base counter, let's implement that one. So I kitchen object parent. And for the functions, let's do the same thing. So let's cut this one from here and let's paste it on the base counter. So okay, now we need these 2 points. So let's go ahead, copy all of this. Let's go into the base counter, paste it. Except for the base one doesn't need a kitchen object so just the counter top point and the kitchen object. Okay, so there are no errors on this one. Let's go into the container. Let's get rid of the kitchen object and the counter top point. Okay, great. Now we see an error, but before we worry about that, let's actually go into the clear counter and let's do the same thing. So let's get rid of this, and down here get rid of all these functions. Okay, so now the counter scripts are much more simple. All of the common code is now written directly on the base counter. Now for solving this, the container counter needs to know if there's a kitchen object on top of it. So now here we have an interesting question with 2 possible approaches. Basically, we need access to this object. So one approach would be to make this protected. Like I said, protected means that any classes that extend this base counter class, any of those classes can then modify that field. So like this, yep, there's no more errors. That's one approach. And the other approach is to instead keep this one as private. And whenever we want to interact with it, we simply interact through these functions. Both approaches can work, and when in doubt, as usual, you should probably go with the more limited option. So let's leave it as private and work with these functions instead. Over here on the container counter, instead of testing if the kitchen object is null, let's just test has kitchen object. So if it does not have a kitchen object, then we're going to spawn it. And for spawning over here, we could grab the actual transform follow. So this one up here, we could call this function to get it. Or since that is actually going to be handled automatically when we call this function to set the parent, then let's actually not use this at all. So we just spawn it and set the kitchen object parent. Okay, great. So now let's just look at the clear counter. For this one, like I said, it's not really meant to spawn anything. So let's actually remove all of this code. This one is only going to serve to pick up and drop items. We're going to handle that in the next lecture. But for now, let's just go back into the container counter. And let's do the proper logic that I mentioned in the beginning. Basically on this one, we want to spawn the object and we want to immediately give it to the player. So when we call setKitchenObjectParent, instead of passing in this, let's pass in the player reference. And that's really it. For the container counter, this is all we're going to do. So the player interacts and it spawns an object and gives it to the player. Okay, so that's it with this. As you can see, the code for all of our counters is much more simplified. So basically it only handles the logic related to that specific counter. Everything else is on the base counter. So let's test this. So here we are, and if I approach the counter and interact, and yep, there you go, spawn some cheese and gave it to the player. Okay, great. Now, just for fun, when I made these assets, I actually included a nice animation. So if you go inside the container counter, over here on the visual, note how this already has an animator with an animator controller attached to it. You can double click to open it up. And over here you can see it's very simple. Basically just has 2 animations. One is the container close and one is the container opening and closing. These transitions are basically triggered by this parameter. This is a trigger parameter. So when triggers goes into the open close, and when this one ends goes back into close. So let's just quickly add these nice animations. However, again, as usual, let's make sure to write some good clean code. So let's not add the visual over here on the logic script. Instead, let's make a proper new script. Over here, let's create a new C# script. Call this the container counter visual. Okay, now we want to attach this only to the visual game object, so only this one let's attach, okay. And over here, the first thing we need is to get the animator. So let's store a field for the animator. And since it's on the exact same object, we can just make an awake and get component of type animator. And we just assign this field, okay. So with this, we have the animator. Now we just need to know when we should play the animation. So let's go over here on the container counter script, and basically let's make an event that we're going to fire when the player grabs an object. So let's make a public event of type, let's stick with the standard. So let's use event handler inside using system, okay. Let's name this on player grabbed object. And then down here, when the player interacts and gets an object, let's fire off this event. So invoke, let's invoke with this an event args.empty. Okay, so we are firing off this event. And over here on the visual, first we need the field for the container counter. So let's add it up here. Let's add a serialized field of type container counter. Okay, we have this field. Now let's listen to the event. But again, we're accessing an external reference. So let's make sure to do it on start and not on awake. So let's go into this one and listen to the onPlayerGrabbedObject event. Okay, so here we have the event. And it's over here that we want to access the animator and call setTrigger in order to play the animation. Again, when working with animator parameters, sadly we do need to use strings. There's no way around that, but at least we can make it a bit more clean by defining a constant. So up here, a private const string, call it open close, and let's make sure to use the exact same parameter name, so open close. And then down here on the setTrigger, let's call this trigger. Okay, so that's it, some very simple visual logic. And now over here inside the prefab, all we need is to drag the container counter reference, so let's drag it. Also make sure that it has the animator and the animator controller. So with that, everything should already be set up. So let's go back into the scenes, save the changes, and let's hit on play. So here we are, and if I go towards the tomato and interact, and there I go, it plays a nice little animation. All right, awesome. Okay, so here we created a brand new counter type, and we refactored our interact code to be able to interact with any counter type. The player can interact with the container counter to pick up an object. Now, the next obvious thing that we need is to enable the player to drop an object on the clear counter, so let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to enable the player to pick up and drop objects. Okay, so we already have the player working. I can approach this container counter, interact with it, and yep, the player picks up something. Now that's left is being able to approach a clear counter and being able to drop this object, so let's do that. Let's go over here on the clear counter script. And when we interact with it, we're going to do a bit of logic. First, let's just check if this counter is empty, meaning if there's no kitchen object on it. So let's test if has kitchen object or if not. So let's say if we don't have a kitchen object, then there is no kitchen object here. And if not, then there is a kitchen object here. Okay, these are the two valid options. So if there is nothing here, then let's check the player itself. So we go into the player and we can ask the same question. So has kitchen object. So if the player is carrying something. So over here, the player is carrying something. If so, then basically we just want to drop that object from the player and drop it in here. So that's very simple. We just go into the player, we get the kitchen object that the player is holding, and we just modify the kitchen object parent onto this object. All right, so that's it. Just with this, it should already be working. Let's do a quick test before we handle the rest of the interactions. Okay, so here moving the player, and if I just interact with the clear counter, and nope, nothing happens. Okay, great. Since the player is not carrying anything, nope, nothing happens. All right, great. Now let's pick up something from the container counter. Okay, so now the player is carrying a tomato, approach the clear counter, press the button, and yep, there you go, there it is. All right, awesome, everything worked. Now this is an excellent point to know just how easy this was to implement, and the reason why it was so easy was because we focused hard on writing some good clean code for how the object and the parent system works. Because we took some time to think about that, it was now very easy to implement this brand new action. So this is a very, very clear example of the power of writing good clean code. Okay, so with that now let's implement the rest. So over here there's no kitchen object here and the player is carrying something, but if not we've got the else, so player has nothing. So if the player doesn't have anything, so let's not do anything. So player not carrying anything. So those are all the possible states up there. And then down here, if there is a kitchen object on this clear counter. If so, then let's check if the player has a kitchen object. So in this, the player is carrying something. And if not, then the player is not carrying anything. So basically, if there is a kitchen object here and the player is carrying something, if so, then we don't want to do anything since we can't give the player 2 items. However, if there is a kitchen object here and the player is not carrying anything, then we want to give it to the player. So let's just get the kitchen object, the one that is on this clear counter. And let's do the exact same thing. So set the parent and set the parent onto the player. Okay, so that's it. As you can see, some very simple logic. So let's test. Okay, here we are, and if we interact, nope, nothing happens. Okay, great. Now pick up a tomato, go there, drop it, yep, there it is. Now if I interact again, yep, there you go, I picked it up again. So I can go somewhere, pick it up, drop it, and everything works perfectly. All right, awesome. Now the last thing that we need to fix is the container counter. Right now it's giving out an object every time, even if the player has something. So if I pick up, yep, it works. Now if I pick up again, there you go, we've got our nice harmful error. This should never happen. So let's set some nice checks. So over here on the container counter, okay, we have our interaction. And before we spawn anything, let's just see if the player can pick up something. So once again, very simple. Let's just go into the player and we check, does the player have a kitchen object? If so, we're not going to give it anything. But if the player does not have a kitchen object, then yep, the player picks it up and we give it the object. Okay, so that's it. It's this simple. Let's test. So here we are, let's pick up some cheese. Okay, great, now pick up another one, and nope, nothing happens. Okay, great, we're already carrying something, so we cannot drop anything. Now drop it in there, now pick up a tomato, and yep, it works. I can pick it up, drop it, and yep, everything works. Okay, great. Let's just do one more thing. Over here, the container counter is spawning the object, and the object is the one that we assigned. So over here in scene view, we've got the container counter. This one is placed on the scene, and we made an override to spawn a cheese block. Technically, we could keep doing this. Pretty much just duplicate objects, modify the sprite, modify over here the kitchen object. That would work. But another better approach would be to simply make some prefab variants. And yep, that does work. You can make a variant of a variant. So let's do exactly that. Over here on the container counter, let's right click, go into create, let's create another prefab variant. And let's say container counter, this one will be the tomato. Now let's go inside the prefab. And over here, make sure it has the kitchen object for a tomato. Okay, great. And over there on the sprite. So let's find the object sprite and choose the tomato sprite. So there you go, this one. Okay, let's exit and save. All right, now once again, let's right click on the container and let's make yet another one. This is going to be the one for the cheese block. So let's go inside of it and over here, modify it for the cheese block. And inside the actual visual, let's modify the sprite, and it's actually down, so the cheese block. Okay, great. Let's go back outside. And since we're here doing this, let's make all of the other grabbable objects from the containers. So let's first make the kitchen object SO. So let's go over here. We can right click, go into create new kitchen object SO. Let's make one for the bread. Then let's duplicate this one. We're going to have a cabbage. And finally, we're going to have the meat patty uncooked. All right, so now let's make sure to assign all the data for all these scriptable objects. First, we need to make the actual kitchen object. So let's duplicate tomato, name this one bread. Let's go inside of it. And first for the kitchen object itself, let's make sure to drag the correct one. Okay, there's the bread. And for the visual, this one is not a tomato. So let's go inside our visual assets, inside the prefab visuals. Let's pick up the bread visual. Okay, there it is. That's all we need. So let's go outside, save the changes. And then select the bread scriptable object, drag the prefab reference, okay? For the sprite, this is the bread, and finally just call it bread. Okay, let's do the same thing for the other one. So next up for the cabbage, let's do the cabbage, drag the cabbage scriptable object. Let's go inside and modify the visual, so the cabbage visual. Okay, that's it. Then on the cabbage scriptable object, drag the reference for the prefab. Let's assign the sprite, and finally give it a name, cabbage. And finally, the meat patty uncooked. So let's do that one. So let's duplicate it, name it meat patty uncooked. Let's go inside, modify the kitchen object SO for this one. And for the visual, let's select, here it is, the meat patty uncooked. Okay, let's go back outside. And on the scriptable object, let's just drag the prefab, assign the sprite. So this one is the uncooked, so it's this one. And finally, meat patty uncooked. Okay, great. So we added all of these scriptable objects. We also have the prefabs with the visuals and the logic script. Now let's just make the container counter. So once again, let's create another variant. So prefab variant, this one is for, let's say for the bread. Then let's make all the other ones already. So let's go make another prefab variant. This one is going to be for the meat patty uncooked. And finally, another variant. Also here, make sure you're creating a variant of the container counter. don't make an accident of creating a variant of something else. So let's make another variant, one final one. And this one is going to be for the cabbage. Okay, we have all the variants. Now let's just assign them. So let's go inside the bread. And over there, modify the scriptable object for the bread. And for the icon, modify for the bread icon. Okay, let's go to the cabbage, save the changes, modify that one for the cabbage. Go into the icon and modify the icon. And finally, the meat patty uncooked. Let's go ahead, modify this one for that one. And the icon, put it on that one. All right, everything is working. Now let's just place them over here in our scene. So let's get rid of the ones that we made some overrides. So let's get rid of that container counter. Instead, for that one, let's drag the cheese block, put it right in there. Let's put it on x of 1.5, y of 0, z of 3.5, okay. Then down here for this one, let's put the cabbage next to it. Let's rotate it to face upwards. So like that. Let's put it on x of minus 1.5, y of 0, and minus 5 on the z. Then for tomato, let's get rid of this one and use the proper tomato one. So let's rotate it, put it on x of 0, y 0, and minus 5. Okay, next we want some bread. So let's put the bread up here on the left side. Let's put it on x of minus 3, 0 on the y, and 3.5 on the z. And finally, the meat patty and cook. Let's put it over here a bit more on the side. Let's put it over here on x of 7.5, 0, and 3.5. All right, so we have positioned all of them. Let's just make some more clear counters so we can actually place the objects. So let's put this one over here on minus 4.5, this one over there. Let's also put some counters, let's say one on the right side, and a bunch more down here. Let's rotate them upwards. Let's put this one on 1.5, minus 5, and one more over here on the side. Okay, great. So we have all of our container counters as well as a bunch of clear counters. So let's test and make sure that everything works. Okay, so here we are. Let's go down, pick up a tomato. Yep, there's a tomato. Now a cabbage. Yep, there's a cabbage. Now some bread. There's some bread. And some cheese. There's some cheese. And some meat. And yep, there's some meat. All right, awesome. Everything works. So with this over here, we added the ability to pick up and drop objects on an empty container and spawn them from all kinds of container counters. Now in the next lecture, let's build a counter we can interact with in a very interesting way. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create a cutting counter. So this is going to be a counter where we can place an object, like for example a tomato, and after doing a secondary interaction, we can slice it. However, before we do that, let's just fix one slightly annoying issue. So right now the player is walking around, okay, that's great, I can approach a counter and interact with it, that's great. However, if I approach a counter from the side, look how the player is pointing towards the right. And if I press the double key, I can indeed select it, but the player does not rotate to face the counter. So that's just a minor visual issue, but still I'd like to fix it, so let's do that very quickly. Basically, the issue is over here on our player script, so we scroll down and find our handle movement function, okay? So here we were doing a bunch of capsule casts in order to fix the problem with the diagonal movement. So you try to move in one direction, if not, try to move in just one of those. And if we can move, then we assign the move direction and then move it. Basically, the problem that we have here is that if I press W to face towards the counter, then over here when we do this logic, so it's going to first attempt the X movement only, and the X is going to be 0, so the move there X is going to be 0, 0, 0, so it won't actually move anywhere, which means it won't be able to move. So this one becomes true, which then sets the move direction to 0, 0, 0, which then down here when we have our rotation, it's not actually going to rotate to anything. So we want the player to still not go through any objects, but we only want to modify the move there over here if we actually move in any of these directions. So the solution is actually super simple. So over here for the can move, we can move if there's nothing on there, and if the move direction.x is not 0. So that's really it. If we are attempting to move in the X at all, and if there's nothing on there, then we can move, which means we then assign the move direction. If not, then we don't touch this. And same thing down here. So we can move if there's nothing on it, and if the move there.z is not 0. So that's it, just this one simple change, and now the player should be able to rotate. So here we are, and if I look over there, and the player is currently looking to the left, and if I press W to point towards the container counter, and if there you go, the player does rotate a little bit. So that feels a bit more natural. Alright, so that's just a tiny visual thing that I wanted to fix, okay, so let's keep going. Now let's handle the actual cutting counter. So first of all, as usual, let's make a counter variant. So let's right click on the base counter, create a new prefab variant, call it the cutting counter. Let's go inside of it. And over here, first thing we need is the visual. So let's pick up from the assets, the cutting counter visual. So here it is. Then we need the selected. So let's duplicate this one. Let's rename this one to selected. And on the animator, let's get rid of it. And instead add the component, the selected counter visual. Okay, great. Now let's drag the visuals for the visual game object array. And by the way, here's a quick tip. On the right side on the inspector, you can see this nice little lock icon. So if you click on it, then that means this inspector will not change as you select other objects. So I can click on and select something different, and this one does not change. It is still showing the selected object. Now this is useful when you want, for example, to drag multiple things. So you can lock the inspector, then the hierarchy, you can use shift click to select multiple objects, and then just drag them all directly inside the array. That's it, just a nice quick tip. So everything is done, let's unlock it, there it is. Okay, so that's set. Let's just assign the selected material. So the counter selected material, let's make it just 1% bigger. So let's select them all, 1.01, okay. And let's start with all of them disabled. Okay, so the basic setup is done. Now let's make our script to run this. So let's go down, let's create a brand new C# script for the cutting counter. Let's select the parent game object and attach the cutting counter, and let's open. Now here, as usual, instead of all this, let's start off by extending the base counter, okay? Once again, thanks to how we set things up using such clean code, this is pretty much all we need to make a counter. With this, the counter already works as a counter. Then the next thing we need is to customize any logic specific to this counter by just overriding the interact function. So that's it. Now over here, we can put whatever logic we want just for the cutting counter. And for this one, for stars, it's actually going to be just like the empty counter, meaning we're going to be able to drop objects on this. So let's just go directly into the clear counter. So here it is. And let's just copy all of this code, go into the cutting counter and paste it. Okay, so the exact same logic. So checks if there's a kitchen object or not, checks if the player is carrying something or not, and picks up or drops it. With this, let's do a quick test just to make sure this one is working exactly like the clear counter. So over here, let's just make sure to drag the last references. So on the cutting counter, let's make sure to drag the counter top point. So drag that reference. And then on the selected, drag the cutting counter reference. Okay, everything is good. Let's exit this prefab, make sure to save all the changes. And over here in the scene view, let's place one of our cutting counters. So let's paste in right in there. Let's put it on X of 4.5, 0, and 3.5. Okay, so let's test. All right, so here we are. Now if I approach and I interact, nope, nothing happens. Okay, great. Pick up some cheese and drop it on there. And yep, there it is. I can pick it up. I can pick up some bread, drop it, and yep, everything works. Okay, so far so good. Now the next goal is to use the knife and actually slice the object that is on there. And for that, the first thing that we need is we're going to need a different input. Right now, we only have the movement and the interaction, so let's add another alt interaction. For that, let's go into our input action, so let's open it up. And over here, let's make another action. So create a new action, call it interact alternate. And for the binding, let's put it on another key. So let's listen, and I think on F makes sense. So let's go ahead, select this one. Then as usual, let's make sure to save the asset, which in turn is going to generate the C# class and compile the code. Okay, great. Now we can go here into our game input class, and let's do the exact same thing we did for the interact action. So first of all, let's listen to it. So let's go inside the player input actions, inside the player action map. So this one is the interact alternate, and let's listen to the performed event. Okay, and when we have that, let's fire off an event, pretty much the same thing. So interact alternate action. And down here, let's just fire off this event. So let's invoke using this and event args.empty. Okay, so we have the input for the interact alternate. Now let's go on the player to listen the same way we were listening to the regular interact action. So over here on the player script, let's see how we're doing things. So we go into game input and listen to that. So let's do the same thing, game input and on interact alternate action. Let's listen to this one. And when this one happens, let's do pretty much exactly the same thing, except we're just going to call a different function. So instead of interact, let's call interact alternate, which in turn obviously means we need to define this function. So let's go into our base counter. So here we are on the base counter, we've got the interact, and let's make another one exactly the same, just a different name, interact alternate. Okay, that's it. And now we are only going to implement this in the ones that need implementation. So for example, on the cutting counter, over here, let's override that one. So public override, and let's override the interact alternate. And now here, let's check if there's something placed on here. So if there's a kitchen object placed on this counter, if so, then let's basically cut it. And for cutting it, the simplest way is really to destroy whatever object is on there and just spawn the slice object. So let's handle destroying a kitchen object. For handling that, let's go over here on the kitchen object script. And let's make a simple function for this object to destroy itself. So let's go up here, make it public, return void. And for the name, I like to use the name destroy self to make it destroy this object. And really all we need to do is just destroy and call destroy on this game object. However, before we do, let's make sure to clear the parent. So let's go into the kitchen object parent, clear it, and then destroy the game object. Okay, that's great. It's really this simple. And then on the cutting counter, let's get the kitchen object that is on here and tell it to destroy itself. Okay, so that destroys the object. And after we do, let's just spawn the slices object. So for now, just keep things simple. Let's make a direct reference up here. So let's make a serialized field. Let's make it of type kitchen object SO, and for the cut kitchen object SO. Okay, so we have this. Then here in the editor, let's make sure to drag the reference. So let's go inside the cutting counter. Let's open up the prefab, and inside, let's assign this one. That means we need to create the object. So let's actually do that first. So let's create a brand new kitchen object SO. Let's call it for the tomato slices. Then if we do this, we need to create the prefab. So let's once again do the same thing. Tomato slices, make the prefab. Let's go inside this prefab. Let's modify the visual. So use the tomato slices visual. Okay, and drag the reference for the other kitchen object for the tomato slices. Okay, so the visual prefab is good. And let's just go into the kitchen object. Let's just make sure to drag the prefab reference. Then let's assign the tomato slices icon and just call it tomato slices. Okay, so we have the kitchen object SO. Now we can go into the kitchen cutting counter. And over here, let's open up and set this one to the tomato slices. Okay, so we have all the references. Let's go back outside, save it. And back over here in our code. So we have this. Now we just need to spawn this object. So we're really just going to spawn it pretty much exactly like we did over here on the container. So we just go into the scriptable object, spawn the prefab, and set the parent. So let's do exactly that. Over here, we destroy the object. Then we instantiate the cut kitchen object. And instead of getting into the player, let's put it on this. Okay, so that's it. We should be able to place a tomato directly on top of the cutting counter, and it should be able to transform from a tomato into a tomato slices. Okay, so here we are. Let me pick up a tomato, go up there, drop it, and okay, that works. Now if I press the Alt Interact key, press it, and yep, there you go, it did work. The tomato was destroyed, and the tomato slices were spawned, and now I can pick them up, place them anywhere, and yep, everything works. Alright, awesome. So with this, the basics are fully working. Let's just briefly clean up this code. We already saw a little bit of code duplication. So the cutting counter is going to spawn an object, and the container counter is also spawning an object. So we're copy-pasting these two lines of code in multiple places. So instead of doing that, let's put it in just one place. And actually a good place to put this is on the kitchen object class itself. So it makes sense that this one is responsible for spawning more objects. So let's put it over here. However, let us not make it a regular function. Instead, let us make it a static function. Again, just like we saw for the singletons, by making it static, it means that the function is going to belong to the class itself as opposed to any instance. So let's go all the way down to the bottom of the file. Personally, I like to put statics at the end. And over here, let's make public, make it static. We're going to return a kitchen object. And let's call it just spawn kitchen object. And for our parameters, let's receive the kitchen object SO. And let's also receive the kitchen object parent. Okay, so that's it. And we're going to do the exact same thing. So let's go into the cutting counter and copy the code that we were using. And over here, just paste it in there. So we go inside here, spawn the prefab, and set it on this parent. And finally, let's return it. So let's return the kitchen object. Over here, let's pick it up. So the kitchen object, we get it. And then we do kitchen object, set the parent. And finally, we return the kitchen object. All right, so that's it. Here we have a super simple function that we can call very easily. it will automatically spawn an object and set the parent. So now let's just call this from somewhere. So over here on the cutting counter, instead of doing all this, let's just go into the kitchen object. Again, remember, let's go through the class name itself and not any instance. And over here, let's call the function, pass in the cut kitchen object so, and for the parent, it's going to be this. All right, so that is now much, much simpler. And let's do the same thing over here on the container counter. So if the player is not carrying anything, let's give the player this object and give it to the player, just like this. As usual, when we do some kind of refactoring, let's do a quick test to make sure everything still works exactly the same. Okay, so here we are, and if I go to the counter and pick it up, yep, it does work, does spawn the object. Now I can drop it in there, I can cut it, and yep, there you go, everything does work. All right, so far so good. So with all of this, basically we have created a brand new counter where we can cut objects. However, right now there's obviously one huge glaring flaw. If I now pick up a cabbage and I drop it on the cutting counter and I interact with it, that cabbage has suddenly magically turned into tomato slices. Now that is obviously not intended. So for that, let's define a proper cutting recipe, and let's do that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to create another scriptable object type. This one is going to be for handling our cutting recipes. So here's our game. I can pick up a tomato, drop it on the cutting counter, cut it, and there you go, slice tomatoes. However, if I could pick up a cabbage, go there, cut it, and there you go, cabbage turns into tomatoes. So we have an obvious issue. The cutting object is currently hard-coded instead of being based on the object we put on top of it. So to solve that, let's make another scriptable object type. Like I mentioned, scriptable objects are excellent for storing and organizing data, so it's perfect for this use case. Basically, we want a scriptable object to hold a reference to the regular object and the cut object, so we can then identify the input in order to spawn the output. Okay, so let's build that. Let's create a brand new C# script. Call it the cutting recipe so, and let's open it. Okay, so now here let's do exactly that. So something extremely simple. So instead of mono behavior, this one is a scriptable object. Let's add the create asset menu. And finally for the fields, let's do just an input and output. So we've got of type kitchen object so. Let's go for the input and another one for the output. Okay, so that's really it. Super simple. Now here in the editor, before we create it, let's keep things organized. So let's make another folder. Let's make it for the cutting recipe so. And inside, let's right click, create a new cutting recipe. Let's call it tomato to tomato slices. And over here, let's select the reference. So the input is going to be our tomato and the output, the tomato slices. Okay, so this is how we're going to handle things. So let's go ahead and make actually the final kitchen object so's. So let's make yet another one, a kitchen object so. Let's make it for the cabbage slices. And then let's have another one for the cheese slices. Okay, so now let's make these. So as usual, let's duplicate tomato, make the cheese slices, and another one for the cabbage slices. Let's go inside of it. And first of all, drag the kitchen object so. So this one is the cabbage slices. And let's go modify the visual. So instead of this one, the cabbage slices. Okay. So we have this. Let's save the prefab, go outside. Then the other one we made, the cheese slices. So let's swap this out. Let's find the cheese slices and modify the kitchen object so. Okay. So finally, just assign the references. So on the cheese slices, drag the cheese slices prefab. Let's assign the icon and call it cheese slices. Okay, so finally on the cabbage slices, so these are the cabbage slices. Let's pick up the icon and let's drag the prefab reference. Okay, so far so good. We have created our new icons. And over here, let's just make all of the other cutting recipes. So we've got two more. So one is going to be the cheese block onto cheese slices. And the other one is going to be cabbage onto cabbage slices. So all we need is just to drag drop the scriptable objects. So for this one, cabbage, let's drop the cabbage on the input, cabbage slices on the output. For the cheese block, that's the cheese block on the input and the cheese slices on the output. Okay, great. All of our data is now stored in some really nice scriptable objects. So now let's go here into our cutting counter. Instead of having a hard-coded kitchen object, let's receive a field of type cutting recipe so, except we're going to have multiple. So let's actually make an array of this. Call it the cutting recipe so array. Now for the interaction, this is picking up and dropping things, so let's leave that the same for now. And over here on the alternate, Basically, we need to find out which recipe we should apply to this. So how I identify that is pretty simple. So we've got the kitchen object that is placed on this object, and we've got a list of cutting recipes, which in turn has the input. So we just need to cycle through all the recipes in order to find the one where the input matches. Okay, so let's go down here, make a function to do just that. Let's make it private. We're going to return a kitchen object SO. Let's call it get output for input. So we give it a certain input and returns the one that matches that one. So it takes a kitchen object SO for the input kitchen object SO. And now here, let's cycle. So do a for each cutting recipe SO in the cutting recipe SO array. So let's cycle through all of these and just check if the cutting recipe SO, if this one dot input matches the input that we received. If so, then this is the one we want. So let's return the cutting recipe SO dot output. And to make sure that the function works, down here, let's return null. Okay, so that's it. We give it an input and we get back the output. So now up here, we just need to make sure to do it before we destroy the current kitchen object. So let's store a kitchen object SO for the output kitchen object SO. And we just get the output from the input. And for the input, pass in the get kitchen object. So that's the one inside of this cutting counter. And let's get the kitchen object SO. So that gives us the output. And then we just spawn that output. Okay, so that's it. Let's test. Finally, back in the scene, let's just go inside the prefab. And over here on cutting counter, we need to make sure to add all of the recipes. So let's add, so the cabbage, then a second one for the cheese block, and finally for the tomato. Okay, so there are all of our recipes. Let's go outside, save the changes, and let's test. Okay, so over here, let's pick up a tomato, go up there, slice it. There you go, got some tomato slices. Now pick up some cheese, go here, slice it, and there you go, got some cheese slices. And finally the cabbage, go up there, slice it, and there you go, some cabbage slices. All right, awesome. So everything is working perfectly. However, now let's say that I want to pick up some bread, and bread should not really be able to be cut. So if I go ahead and I cut it, and there you go, there's our error. We have no recipe that takes bread as an input, so that obviously leads to a null reference exception. Now here we have two options for solving this problem. One option is simply over here when we do the interact alternate. We get the output for the input, and if this one returns null, then we just don't cut it. So we don't destroy it and we don't spawn it. Or alternatively, we can actually add some validation over here when dropping objects. So we can make sure that we only drop valid cuttable objects. Now both approaches are valid, and actually we do need to implement both of them. We'll see why in a bit. So let's do both, starting off with the validating the drop. So first we check if there's no kitchen object on this cutting counter. Then we check if the player is carrying something, and then we drop it from the player on this. So over here, let's just check if there's any recipe that has whatever the player has as an input. So let's go down here, make a function to do that, private. Let's return a bool and call it has recipe with input. And we're going to receive a kitchen object SO for the input kitchen object SO. And over here, let's do pretty much literally the same logic. So we have this, and if we find a match, then let's return true. So there's a recipe with that input. If not, return false. So now up here, when the player is carrying something, let's check if has recipe with input and give it the player, get the kitchen object the player is holding, and get the kitchen object SO. So if there's any recipe that takes whatever the player is carrying as an input, if so, then we drop it. Okay, so like this, let's test and see if we can drop the bread. Okay, so let's pick up some bread, go ahead, drop it, and nope, does not work. Pick up some cheese, and yep, that one does work. However, now we actually also need the other validation that I mentioned. The reason is because if we place a valid object, like for example the cheese there, so that works, and I can cut it, and yep, that does work. However, now the recipe, the cheese block, became cheese slices, and now cheese slice is no longer an input to any cutting recipe. So now if I try cutting again, yep, there you go, I've got another null reference exception. So we need to validate putting objects on top of it and also actually cutting them. That logic is also pretty simple, so let's go down to the interact alternate. So we just check if there's a kitchen object on the cutting counter and has recipe input. And let's get this kitchen object, get kitchen object SO, just like this. So we're only going to cut if there is a kitchen object here and it can be cut. Okay, so let's test. So first of all, the other one, let's pick up bread and nope, cannot drop. Okay, great. Now pick up some cheese and I can drop. Now interact, cut, now cut again. And yep, there you go. No more errors. All right, awesome. Okay, so here we have everything working perfectly. I can pick up a cabbage, go up there, cut it into slices. I can slice some cheese and I can even slice some tomatoes. Everything works perfectly. Now, the one thing missing from our design is we don't actually want this action to be instant. We don't want to just press a button, everything slices instantly. Instead, we want to have the player press the button a few times in order to actually cut. So let's do all that in the next lecture. Hello and welcome, I'm your Code Monkey. In this lecture, we're going to add the mechanic for the player to be able to cut multiple times in order to actually cut an object. Okay, so we have our cutting counter. I can drop a tomato and press a button. There you go, it cuts it straight away. Now we want the exact same logic, but we want it to take a few cuts before the cut object is spawned. So let's start off by going here onto the cutting counter. And basically, let's keep track of some kind of progress. Basically, the way we do that is pretty arbitrary. It's up to you to decide. For example, you could use a normalized float. However, for cutting, since this is going to be a discrete action, let's actually count the numbers with an int. So let's store a private int, just call it cutting progress. Okay, so now let's begin by actually initializing this progress. So when the player drops something on there, let's set this one to 0. And then down here, when we have the interact alternate, we do our logic, and when we do, let's just increase this by 1. And now we need to know if the object has been cut, so we need somewhere to define some kind of maximum. And for that, we can actually do it directly on the recipe SO. So inside the cutting recipe SO, over here we've got the input, we've got the output, and let's also define an int for the cutting progress max. Okay, that's it. And back here in the editor, let's go into the tomato to tomato slices. Let's say this one takes just 3 cuts. Then for the cheese, let's also take 3 cuts. And for the cabbage, let's say it's a bit thicker, so let's say it takes 5 cuts. Okay, so back in the cutting counter here. Down here, we are adding to our cutting progress. So then we just need the recipe SO in order to grab the maximum. So let's actually go down here and actually make a different function. So this one just returns a boolean. This one a kitchen object SO. Let's make another one. This one is going to return a cutting recipe SO. So get the cutting recipe SO with input. And we're going to receive, as usual, the kitchen object SO for the input. And really going to do the exact same thing that we did up here, except instead of returning the output, let's return the recipe itself. Okay, so now that we have this more logical one, we can actually get rid of all of this copy-pasted code. So over here, we just get the cutting recipe SO, and we just get it and pass in the input. So we have this one over here. If this one is not null, then we're going to return this one .output. And if not, we're just going to return null. Okay, so we're doing the exact same logic, just a bit simpler, okay? And up here, pretty much the same thing. So has recipe with input. Let's get the cutting recipe SO. And basically just return if this one is not null. Okay, so we have our 3 nice helper functions. So let's just use this one to get the cutting recipe SO. So let's actually copy this and go up here. So we do the cutting progress. Then let's pick it up, the one for this input. So the input is going to be this one, the object currently on the cutting counter. And over here, we already know that there's going to be a recipe with this input since we've gone through this if. So then we can just check if the cutting progress is bigger or equal to the cutting recipe SO. And let's grab the maximum. If so, then yep, we do spawn it. Okay, so that's it. Some very simple logic. Let's test. So here we are, let's pick up a tomato, go up there, and okay, now I'm going to press the alt to interact. Okay, press once, and yep, okay, so far so good, nothing. Now 2 times, and now if I press a 3rd time, boom, and yep, there you go, got the nice slices. Now for cheese, same thing, 1, 2, 3, yep, it works. And finally for the cabbage, this one should be 5. So 1, 2, 3, 4, and 5. And yep, there you go, everything does work perfectly. All right, awesome. So with this, we now have progress in our cutting logic. Although, of course, just like this, it's not very good for the player. The player has no way of knowing what exactly is going on, so we need some kind of visual feedback. So for that, let's add a really nice visual progress bar. And for doing this, we're also going to learn about a really awesome Unity feature. These are world canvases. So before we make the world canvas on the cutting counter, let's actually set something up over here on the scene itself. Let's first create a regular canvas. We're only going to use this in a couple of lectures, but let's first do that one just for now. So let's go on the plus button, go into UI, and let's create a brand new canvas. Okay, so there you go. That creates a canvas and an event system. Now, like I said, we're only going to worry about this in a little bit, but for now, let's just leave those as is. And also, since we're here creating some objects, let's also take some time to organize our hierarchy. Unity sadly doesn't really have any folder objects, so you can't organize the hierarchy in any folders. However, you can use empty game objects essentially as folders. So let's make a brand new empty game object. Let's call it counters. And now, very importantly, for empty folder objects, make sure you put them on 000 so nothing breaks. So make sure you put it on there before you drag the counters. And now let's just drag all the counters inside. So all the clear counters, put them all inside. This one, also drag it inside. And all of these counters, put them all inside. So there you go, now our hierarchy is quite a bit more clean. Okay, so now let's make the cutting progress. So let's click on the cutting counter. And let's go inside our prefab. So let's go inside of it. Now over here, let's right click on the hierarchy and we're going to create a UI. Let's create another canvas. Now for this one, let's give it a name. Let's name it the progress bar UI. And for this one over here on the inspector for the settings, instead of being screen space overlay, let's make this one a world space canvas. Basically, screen space means that it would occupy the entire screen, whereas world space means that this exists in the world in whatever position it is. So let's make it world space, and over here the fields actually unlock. So let's put the positions all on 0, and for the width and height, let's also put it on 0. So basically the canvas is going to be exactly over here. By the way, the shortcut that I just used was the F in order to focus on the object. So this is useful if you're zoomed out or zoomed in way too much, okay? So we have this and we want the bar to be a little bit above, so let's actually lift it up on the Y by a little bit. So over here, let's put it on a Y of 2.5, okay. Now, like I said, the goal with this is to make a progress bar. So inside the progress bar UI, let's create a new UI image. Let's name this one our bar. Let's put it with a width of 1 and a height maybe of 0.2. So there you go, just a really thin bar. And for the color, you can play around, tint it with any color you want. Now for progress, I think maybe a blue or a yellow, something like that makes sense. So let's go with the yellow, kind of like this. Okay, so there's our really nice progress bar. And for this, let's actually use one really nice trick for making a super easy progress bar. The image component has a really easy way of making a slider image. However, it only actually works if you assign an image over here. So let's assign one in order to be able to see those options. And for that, in the included project files, there's a texture white 1x1. This is literally just a 1x1 white pixel. So here it is, just a 1x1 image, fully white. And as soon as we assign it, we do see over here the image type. So we see a bunch more options. And the one that we want is to set the sprite as filled. This one lets you do some really cool, really easy effects. For example, you can make it radial, and look at what happens in there as I modify over here on the fill amount. So as I go down, look at that, it's radially filling. So for some kind of circular progress bar, this would be excellent. But in our case, what we really want is just a horizontal bar. So over here for the fill method, instead of radial, let's go with horizontal. And yep, there you go. Now by playing around this, we have a really nice progress bar. Then if you want, you can modify left to right, right to left, but yep, like this, it looks great. Now in order to modify this visual, really all we're going to need is modify over here the fill amount. This one is a normalized value, so between 0 and 1. So 0 is completely empty, 1 is completely full. However, one issue with this is when the bar is empty, then we can pretty much not see, so we can't see the actual size of the bar. We can see what size it should be. So with this, it's pretty difficult to see how far along we are. But solving that is pretty simple. We can really just add some kind of background. So let's duplicate the bar. Let's name this one the background. For this one, for the image type, we don't want anything, so let's leave it on simple. And for the color, let's put it on kind of a dark gray. Okay, great. And now here's one very, very important thing, is over here on the hierarchy, let's click and drag and place it above the bar.